In question 1, we need to find the first 4 terms in ascending powers of x in the binomial expansion of this here. So we have 2 plus 3 over 8x raised to the power of 10. So we start with the full power loaded onto 2, so it's 2 to the 10, plus 10, choose 1, 2 to the power of 9, 3 over 8x. Notice that the power drops by 1 in the first term and increases by 1 in the second term. Plus 10, choose 2, 2 to the power of 8, 3 over 8x squared. Notice the brackets is on the whole term of 3 over 8x. Plus 10, choose 3, 2 to the power of 7, 3 over 8x to the power of 3, plus dot dot dot. We are only after the first 4 terms. So this gives 1024 plus 1920x plus 1620x squared plus 810x cubed. In question 2, the first part, we need to fill in the table with the y values for x is 1 and x is 2. We use our calculator, we give answers to 3 decimal places. So when x is 1, y is 1.075, and when x is 2, y is 1.041. In part B, we need to use a trapezium rule with the values we obtained in the table to estimate the given integral. So we start by writing out that we need to integrate from 0.5 up to 3 of 1 minus log of sine x base 10. And this will be approximated by a half times the height of the trapezia, which is the difference between 2 consecutive values of x on our table. And then it's going to be the first and last y values once, and then all intermediate values of y twice. So 2 times 1.075 plus 1.001 plus 1.041 plus 1.223. Plug everything on the calculator, you get an answer of 2.96. In C, we need to use our answer to part B to estimate this integral here. So somehow we need to build a connection between these two integrals so that we can use the answer to part B. So we need to estimate the integral of 3 plus log of sine x base 10 dx from 0.5 up to 3. And I start by writing the 3 as 4 minus 1 in order to make it communicate, let's say, with the answer to part B. So it's now the integral of 4 minus 1 plus log sine x, which can be written as the integral from 0.5 up to 3 of 4 minus brackets 1 minus log of sine x base 10 dx. And I can now split this into the integral of 4 with respect to x from 0.5 up to 3 minus the integral of 1 minus log of sine x base 10 dx from 0.5 up to 3. And we notice that this integral here is exactly what we have estimated with the trapezium rule. So this will be approximately 4x from 0.5 up to 3. So the first integral can be done analytically, minus 2.96, which is 4 times 3, I'm substituting the upper limit, minus 4 times a half, the lower limit, minus 2.96, which gives an answer of 7.04. In question 3, we've got 2 independent parts. They are both on proofs. The first one says that show that the following statement is false, and we've got n plus 1 cubed minus n cubed is prime for all n in the natural numbers. Now the natural numbers are all positive integers, so 1, 2, 3, and so on. So we need to come up with a specific example, a particular value for n for which the following statement is false. This does involve some trial and error, and we end up that if we consider n to be 5, then substituting into n plus 1 cubed minus n cubed, the value of n is 5, we get 5 plus 1 cubed minus 5 cubed, which is 6 cubed minus 5 cubed, which is 91. Well, 91 is 7 times 13, and therefore the statement is false. In II, we've got 3 points. The coordinates are given. We know that they lie on a circle, and we need to prove that AB is the diameter of this circle. Now in this case it makes sense to draw a quick diagram, a circle, just put the points there just to get a visual understanding of what's happening. So there it is, I've got the points there. The relative position doesn't really matter. What matters is that if AB is indeed a diameter, then I expect the angle C here to be 90 degrees, and I will be basing my proof into considering gradients. So if we manage to show that BC is perpendicular to AC, then we will be done. So we start with the gradient of BC, which is minus 10 minus 6 over 3 minus 7. We're using y2 minus y1 over x2 minus x1. It turns out to be 1. And the gradient of AC is minus 6 minus 0 over 7 minus 1, which is negative 1. We explicitly state that the gradient of BC times the gradient of AC is equal to negative 1, and therefore we conclude that ACB is 90 degrees, and therefore because we know that the angle in a semicircle is a right angle, is 90 degrees, then it must be the case that AB is the diameter as we were required to show. In question 4, we need to solve the two simultaneous equations given that A and B are positive constants. So starting with the second one, log of A base 4 plus log of B base 4 is equal to 3. I can combine this into a single logarithm. Log of AB base 4 is equal to 3, and therefore AB is 4 to the 3, which is 64. And I can say that B is 64 over A. We can now substitute B 64 over A into A minus B is equal to 8. And we get A minus 64 over A is equal to 8. I will multiply throughout by A to get A squared minus 64 is 8A. And therefore A squared minus 8A minus 64 is 0. I will be using the quadratic formula here. So A is minus 8 plus minus 8 squared minus 4 times 1 times minus 64 square root and all of it over 2 times 1. This simplifies into A being 4 plus minus 4 root 5. However, we are told that A is positive, so since A is positive, then A must be 4 plus 4 root 5, because 4 minus 4 root 5 will turn out to be negative. I will now substitute this value into the equation A minus B is A to get 4 plus 4 root 5 minus B is equal to 8, and therefore 4 plus 4 root 5 minus 8 is equal to B, which leads to minus 4 plus 4 root 5 is equal to B. That's the value for B. In question 5, we've got a trigonometric equation to be solved. We are in degree mode between minus 180 to 180. So I will actually start by writing tan as sine over cos. So we've got 3 sine theta plus 43 over cos of theta plus 43 is equal to 2 cos of theta plus 43. I will now cross multiply to get 3 sine of theta plus 43 is equal to 2 cos squared of theta plus 43. And now I'm using the identity that sine squared plus cos squared is 1 to get 3 sine of theta plus 43 is equal to 2 times 1 minus sine squared of theta plus 43. So I'm trying to get a quadratic in sine here. So 3 sine of theta plus 43 is equal to 2 minus 2 sine squared of theta plus 43. Collecting everything on the left hand side is 2 sine squared of theta plus 43 plus 3 sine of theta plus 43 minus 2 is equal to 0. Now this factorizes into 2 sine of theta plus 43 minus 1 and sine of theta plus 43 plus 2, which means that either 2 sine of theta plus 43 is equal to 1, or sine of theta plus 43 is equal to negative 2. Obviously, we cannot have sine of any angle giving a result of negative 2, so we reject this, it's not valid. And we turn our attention to the left-hand side. We've got sine of theta plus 43 is a half, and so the principal value will be shift sine over half, which gives an answer of 30. And therefore we've got that theta plus 43 is 30 plus 360k, or theta plus 43 is 180 minus 30 plus 360k. So leaving theta on its own gives me that theta is minus 13 plus 360k, or theta is 107 plus 360k. The only solutions within the range of minus 180 to 180 are theta is minus 13 and theta is 107. In question 6, we have a geometric sequence. The second and third terms add up to 6. The fourth term is 8. We need to arrive at this quadratic equation in R. So I will start by writing that U1 is A, U2 is AR, U3 is AR squared, and U4 is AR cubed. Remember that the key property of a geometric sequence that we multiply by the same common ratio to get to the next term. We have that U2 plus U3 is equal to 6, and therefore AR plus AR squared is equal to 6. And we also have that U4 is equal to 8, so AR cubed is equal to 8. So A is 8 over R cubed. So we've got 8R over R cubed plus 8R squared over R cubed is equal to 6. This simplifies to 8 over R squared plus 8 over R is equal to 6. So I can multiply throughout by R squared to get 8 plus 8R is 6R squared. I'll get everything on the right hand side. To get 0 is 6R squared minus 8R minus 8. I will divide throughout by 2, leading to 3R squared minus 4R minus 4 as required. In B, we are told that the geometric sequence has a sum to infinity and we need to find U1. So it makes sense to start off by solving the quadratic in R, which factorizes into 3R plus 2 brackets R minus 2. So either 3R plus 2 is 0 or R minus 2 is 0. So we get that R is minus 2 over 3 or R is 2. We know that for a sum to infinity to exist, for the series to be convergent, we need the common ratio to be between minus 1 and 1, and therefore the R is 2 is rejected since it gives a value which is greater than 1. Now for R is minus 2 over 3, A is 8 over R cubed, so minus 2 over 3 cubed, which gives an answer of negative 27. In part C, we need to find the sum to infinity, and there is a formula for this. The sum to infinity of a convergent geometric sequence is given by A over 1 minus R. So A is negative 27, R is negative 2 over 3. This gives an answer of minus 81 over 5. In question 7, we've got f of x here in terms of a constant A and a constant B. We are told that x plus 2 is a factor of f of x. So if x plus 2 is a factor, this means that f of minus 2 must be 0. This will give an equation involving A and B. So substituting x with negative 2, we get 0 is A times negative 2 cubed plus 6 times negative 2 squared minus 4 times negative 2 plus B, which gives an answer of 0 is minus 8A plus 32 plus B, and therefore we have that 8A minus 32 is equal to B. The second piece of information is that the integral of f of x from 3 to 5 is 176. So we could integrate this from 3 to 5, f of x dx is the integral from 3 to 5 of ax cubed plus 6x squared minus 4x plus b dx. This gives ax to the power of 4 over 4 plus 6x cubed over 3 minus 4x squared over 2. Remember, we are increasing the power by 1, dividing by the new power. The limits are 3 and 5. Now this simplifies into ax to the power of 4 over 4 plus 2x cubed minus 2x squared plus bx from 3 to 5. So we will substitute the upper limit. It will give us a times 5 to the power of 4 over 4 plus 2 times 5 cubed minus 2 times 5 squared plus 5b minus the lower limit substituted, which will be a times 3 to the power of 4 over 4 plus 2 times 3 cubed minus 2 times 3 squared plus 3b, and this gives 136a plus 164 plus 2b, and we have been told that this is 176, so we have that 136a plus 2b is equal to 12, and if I divide throughout by 2, I get 68a plus b is equal to 6. Now we have seen that the b is 8a minus 32, so I'm substituting b. I get 68a plus 8a minus 32 is equal to 6, which leads to 76a is 38. So a is 38 over 76, which is simply a half. We found the value of a. Let's proceed in finding the value of b. We had that b is 8a minus 32, and this gives an answer of negative 28. In question 8, the first part, we need to find dy dx. I will start by writing y in index form, so it's 256x to the power of 4 minus 304x minus 35 plus 27x to the negative 2, and therefore dy dx will be 256 times 4x cubed minus 304 plus 27 times minus 2x to the minus 3, and I will actually write this in a much better form. I will write it as 1024x cubed minus 304 minus 54 over x cubed. That's dy dx. In B, it says hence find the coordinates of the stationary points. We know that stationary points mean that dy dx is 0. So we will be setting the expression we just obtained, 1024x cubed minus 304 minus 54 over x cubed. We set this equal to 0. I will actually let w be x cubed because this means that I have 1024w minus 304 minus 54 over w is equal to 0. I will multiply throughout by w to get 1024w squared minus 304w minus 54 is equal to 0. This is a quadratic in w, so w is minus 304 plus minus 304 squared minus 4a, which is 1024, c, which is minus 54, and all of it over 2a, so 2 times 1024, and this gives that w is 27 over 64, or w is equal to minus 1 over 8. Now recall that w was x cubed, so x cubed is 27 over 64, which means that x is the third root of 27 over 64, which is 3 over 4, or x cubed is minus 1 over 8, so x is the third root of minus 1 over 8, which is minus a half. We haven't finished. We still need to find the corresponding y values. So when x is 3 over 4, we have that y is 256 times 3 over 4 to the power of 4 minus 304 times 3 over 4 minus 35 plus 27 over 3/4 square. We're substituting to the original expression for y. This gives an answer of minus 134, and therefore one stationary point is at 3 over 4 comma minus 134, and the second stationary point is at x is minus a half, which leads to y is 256 times minus a half to the power of 4 minus 304 times minus a half minus 35 plus 27 over minus a half squared. This gives an answer of negative 63, and therefore the second stationary point has coordinates minus a half comma minus 63. In question 9, part A, we are asked to sketch the graph of n against t for k is 1. So in other words, we are asked to sketch the graph of n equals to lambda t. So the graph should look something like this. We have a cut on the vertical axis at 1 because when t is 0, capital N is lambda to the 0, which is 1. It progressively becomes smaller, and we know that it becomes smaller because lambda is between 0 and 1, and the horizontal t-axis is an asymptote. In part B, we need to show that the value of lambda is this one here, given that it takes 5,700 years for the amount to drop to half of its initial value. So we start by writing out the expression for capital N. It's k lambda to the t. If it drops to half of its initial value, it's going to be a half k is equal to k lambda to the 5,700. The k's will cancel out, so a half raised to the power of 1 over 5,700 will give me the value of lambda. It works out to be 0.9998784 ... which rounds to 0.999878 as required. In C, we know that for an item A, we had 15 grams of carbon-14 initially. It is thought to be 3,250 years old, and we need to find to 3SF how much carbon-14 we are predicting currently for item A. So we know that K is 15, that's the initial amount of carbon-14. So capital N is 15 times 0.9998784 raised to the power of 3250, and this gives an answer of 10.1 grams. In D, we have an item B now that it was initially 25 grams of carbon-14 and now only has 18 grams. We need to calculate the age of B to the nearest 100 years. So in this case, we have that 18 is equal to 25 times 0.9998784 to the power of t. So 18 over 25 is the value of lambda raised to the power of t. I could take logs, and I have log of 18 over 25 is equal to log of 0.9998878 to the power of t, which means I can write this as log of 18 over 25 is t times the log of 0.999878, and therefore if I divide the log of 18 over 25 by the log of the lambda, the 0.99878, this should be giving me the value of t. It turns out to be 2701.4, which to the nearest 100 years, it's going to be 2700 years. In question 10, we've got a circle centered at 3, 5, radius r, and a straight line y is 2x plus k. and we need to show that L and C intersect when this relationship holds true. So we start with the circle. We know that it's centered at the point 3, 5 and has a radius r, and therefore its equation will be x minus 3 squared plus y minus 5 squared is equal to r squared. I could expand this to get x squared minus 6x plus 9 plus y squared minus 10y plus 25 is equal to r squared, which simplifies to x squared minus 6x plus y squared minus 10y plus 34 minus r squared is 0. On the other hand, we've got the straight line with equation y is 2x plus k, so I will be substituting y with 2x plus k, leading to x squared minus 6x plus 2x plus k all squared minus 10 times 2x plus k plus 34 minus r squared is equal to 0. We expand this, we get x squared minus 6x plus 4x squared plus 4kx plus k squared minus 20x minus 10k plus 34 minus r squared is 0. I will be collecting like terms. I've got 5x squared minus 26x plus 4kx plus k squared minus 10k plus 34 minus r squared is 0, which leads to 5x squared plus brackets 4k minus 26 close brackets x plus k squared minus 10k plus 34 minus r squared is 0 as required. In B, we are told that L is a tangent to C, and we need to show that this relationship holds true for some constant P to be found. So we know if the line is a tangent, then the discriminant is 0, and we have obtained a quadratic in X. So the B is 4k minus 26, so B squared minus 4a, which is 5, and C, which is k squared minus 10k plus 34 minus r squared. These must be 0 because the line is tangent. So we get 16k squared minus 208k plus 676 minus 20k squared plus 200k minus 680 plus 20r squared is 0. Collecting like terms together leads to minus 4k squared minus 8k minus 4 plus 20r squared is 0. And therefore, dividing throughout by negative 4, we get that k squared plus 2k plus 1 minus 5r squared is 0. Now the k squared plus 2k plus 1 is k plus 1 squared, and the minus 5r squared is taken on the right hand side, so k plus 1 all squared is 5r squared. In C, we are told that the line L is cutting the y-axis at point A and touching the circle at point B. Additionally, we have that AB, the distance AB is 2r, and we are asked to find the value of k. I will start by adding the information I've been given on the diagram here. We are cutting at A, so because the straight line has equation y is 2x plus k, it's obvious that the y-intercept would be at k, and therefore the point A has coordinates 0, k. Now the point X has coordinates 3, 5. It's the center of the circle. So I will start by finding that the distance AX is going to be 5 minus k squared. So y2 minus y1 squared plus x2 minus x1 squared all square root. And this gives me 25 minus 10k plus k squared plus 9. So this further simplifies into the square root of 34 minus 10k plus k squared. Now, in addition, we know that the circle has a radius of r. We know that the distance AB is 2r, and therefore we've got a right angle triangle because the line is tangential, and therefore the angle at the point where the line touches the circle is going to be a right angle. So I can say that the distance AX is simply Pythagoras theorem here. So it's going to be r squared plus 2r all squared square root. This gives me r squared plus 4r squared, which is simply 5r squared square root. And now I could proceed in combining the results we obtained from the previous part. We have already established that 5r squared is k plus 1 all squared. So I can now simply equate these two expressions because they both correspond to the same distance, AX. So we've got that the root of k plus 1 squared is equal to the square root of 34 minus 10k plus k squared. We've got square root on either side of the equation, so they can cancel out. I will expand the k plus 1 squared to give me k squared plus 2k plus 1. This is equal to 34 minus 10k plus k squared. Obviously the k squares, they cancel out, and I'm left with 12k equals to 33. So k is 33 over 12, which simplifies to 11 over 4.